Okay, we were talking about resistors in class, resistors in series, in parallel, and someone asked me, how do I know when you have four resistors, they may be like this, they may be, in a loop, or this is the easiest one to see, but these are all the same circuit. How do you know if they are in series or parallel? And my question was a little weird. Actually, my answer was another question, like, wait a minute, where are you measuring? The first way, the simplest that I can then answer this question is making a ton of circuits here. So let's say I want to measure between A and B. If I am with the multimeter between A and B and the circuit only has these four resistors, even if there's a node here C and a node D, but maybe I'm not doing anything with those nodes, and these are the only things, then the series resistors are 1, 2, and then 3, 4. Hopefully everybody sees this. So this is typical. If you put the multimeter here, I'm measuring the resistance. It's going to be 1 and 2 in series, in parallel with 3 and 4. If, however, I put the multimeter between C and D, so this is where my multimeter will be, then 2 and 4 will be in series. So hopefully you see this one. And then I'm going to make it orange, this node here, 1 and 3. And so they are in series in this case, are 2 and 4, and then 1 and 3. So that's how I cannot answer your question with this who is in series. In principle, it could be that all resistors here are in one loop and they are all in series, but this would make no sense for the rest of the circuit if you're going to do more. Here is another option. If you short C to D, now I'm asking what is the resistance between A and B. In here, they are parallel. The 1 and 3 are in parallel, and 2 and 4 are in parallel. And once you do the parallel of these two and the parallel of these two, those two will be in series. And what we said in class is, and it holds, is that if two branches are attached to the same two nodes, so you see how 1 and 3 are attached, one side to orange, the other side to green, then they are in parallel. 2 and 4 are connected to green and orange and pink, and therefore they're in parallel. So this is by definition how parallel resistors work. Sometimes the Wheatstone bridge is done like this, and in exams I will ask that same question, but it's going to be drawn weirdly like this. This here is the same circuit as this. This and this are equivalent circuits. It's just drawn differently. And then of course I can also short A to B. If I short A to B, this is also the same as this. If you see a circuit like this, and I'm measuring between C and D, so my multimeter is from C to D, I'm going to do the same thing. So C node is going to be the green, and then A and B will be the orange, so I'm going to paint the whole thing here. So hopefully this shows you that in parallel will be 1 and 2, and then 3 and 4 are also in parallel. So I'm going to paint the last node there. D is pink. Painting abilities, art here is not very good. And you see how 3 and 4 are connected between orange and pink. So the two branches, 3 and 4 in parallel, and the other two are in series. Now, there's one other option, which is, there are many other options, but I'm going to talk about one other option, which is I connect a power supply here, and I connect a resistor here, and this is then no resistors are in series or in parallel. So in this case, if I ask you resistors in series, none or zero, resistors in parallel, none or zero. So I hope this helps show how many different circuits you can have just with 4 resistors and 3 nodes, 4 nodes, some between 2 and 4 nodes. But please comment on this video if you have questions or post on Canvas.